Hello and welcome to Chemicals Knowledge Hub TV, your one-stop shop for industry interviews and insight. I'm David, and today we're joined by one of the team from Catalent, a leading global provider of advanced delivery technologies, development and manufacturing solutions for drugs, biologic, cell and gene therapies, and consumer health products. Joining us today is Craig Scott, who is Director of Product Development at Catalent's Swindon facility in the UK. Craig, thank you very much for joining us. Are you actually in the Swindon office at the moment?
I am in the Swindon office, yes.
Aha! And how is social distancing going in your workplace at the moment?
Yeah, it's going not too bad. I mean, we've reduced the footfall on site probably by about half. So I've still got many of my scientists working in the lab, but many of the office-based staff are working from home.
Yeah.
So we've probably got
But
about
as best as it
half the
can
number of
be,
people on site.
as best as it can be, business as usual for now. Listen, here's something I didn't think I'd be saying when I woke up this morning. Let's talk about taste masking, shall we, Craig? And in
No
particular, what the
problem.
challenges are when it comes to taste masking in orally disintegrating dosage forms. Tell us a bit more about that.
Yeah, no problem. So I think for answer the question, I'll just say a little bit about what oral disintegrating tablets are. Essentially, they are what they say on the tin. They disintegrate within the oral cavity, and they're meant to disintegrate rapidly. In fact, the FDA have guidelines to state that they must disintegrate within 30 seconds. The manufacturers have also got to consider the size of the tablet and the weight of the tablet so that they don't present a choking hazard. And obviously, because they dissolve rapidly on the tongue or under the tongue, uh, they can prevent a real challenge for taste. Because many active pharmaceutical ingredients are really foul tasting, or they produce really negative sensations in the mouth, such as stinging or bitterness. So yeah, that really presents as a challenge that we've worked hard to overcome. And
Yeah.
obviously, it
So
can
what is it
present compliance
that you
issues as
guys at
well.
Catalent have been doing to address those? Then what's your approach?
So we've got a number of approaches with APIs that have got quite mild, uh, unpleasant tastes. We can use things like sweeteners or flavors to help mask those, or we can complex the APIs with things like ion exchange resins or cyclodextrins, and those can actually trap the molecule so they're not available for the tongue receptors. But recently, we've developed quite a novel coating technology, which we term as Zydus Ultra. And for this, we use quite a novel technology called resonance acoustic mixing. And it's a technology that's typically used in the ballistics or the accelerants industry. But we've managed to use it to coat APIs. And I can tell you a little bit about that if you want.
Yeah, no. This sounds really interesting and not an obvious source of inspiration. When you talk about the ballistics industry. So, Zydus Ultra, I think that was. So, yeah, how is it different, and how are you using it then?
So typically what we do is we have an API molecule and we mix it with a micronized polymer. But what we do is we put it into an acoustic mixer. And this acoustic
Right.
mixer really uses really high acceleration to collide the API and the polymer in such a way that the API or the polymer will stick around the surface of the API. And the collision energies are really quite intense. The accelerations can get up to about 100 times the force of gravity, up to 100 G.
Wow.
And what that does is it increases the temperature slightly as well, so that the polymer actually deforms around the API, forming quite a thin, continuous layer around the API. And obviously, that helps uh, mask the taste on the tongue. So
Really
it's
interesting
a novel.
stuff. Yeah, really interesting stuff. So, in terms of the medications that you're applying this too. Is there any detriment? Are there any positives? What are the advantages of working in this way?
So I think one of the major advantages, well, for Zydus anyway. I mean, Zydus is I work with Zydus. I think it's a great technology. It's because it's very fast disintegrating. It's very convenient. You can take it without water, which means you can take it on the go. It's a really good product for pediatrics, for geriatrics, and for a lot of disease states where swallowing is a real difficulty. And a good example of that is Parkinson's disease. Mm-hmm. But what we've been able to do with Zydus Ultra is really expand the space which we can work in. We can increase the amount of API we can get into our tablets, which has meant we can look at much more over-the-counter medications such as ibuprofen and paracetamol, where you typically get up to about 200 milligrams or 400 milligrams. Previously, we haven't been able to do that with our standard Zydus formats. So it's really allowed us to look into the OTC space. And essentially, we have been working very closely with ibuprofen quite recently. And we've actually proven that our technology is bioequivalent to the tablets and the suspensions that are on the market.
Right. Exciting stuff. Listen, Craig, thank you very much for taking time out of your busy day to talk to us about what you've been working on over there in Swindon. Well, I wish you all the very best in developing that, and the rest of your operations as we start to emerge out of the coronavirus lockdown over the coming weeks and months. Thanks again for joining us, and I hope to catch up with you again soon.
Thank you very much. Goodbye.